Hello everyone, welcome back to our YouTube channel. In today's discussion, we discuss a very interesting question, and this question is asked in the TIFRCAM PhD entrance exam 2026. And this question is from the functional analysis part, specifically from the Banach fixed point theorem or Banach contraction principle. Okay. In this question, the given f is a continuous function. What is given? F is a continuous function and it satisfies this integral form of equation. Option 1 is saying that there is no such continuous function which satisfies this equation. Option B is saying that there exists exactly one function f which lies in this space and satisfies this equation. Option C is saying that there exist exactly two solutions in this continuous function space which satisfy this equation, and option D is about the infinitely many solutions in C01. We have to check all these options. Okay, but our target is to convert this equation into the Banach fixed point setting. But to apply Banach fixed point theorem, first of all we have to create a Banach space. Okay, and we know that this C01 continuous function space, when it is associated with this supremum norm, it is a Banach space or complete normal space, and this supremum norm is defined in this way. I hope that you all know this result. Okay, so our required Banach space is this one. Then I will create an operator from this x space to x space, and this operator is defined in this way. One can think, how did you get this operator? Means it takes this function g to this expression half times integral from 0 to 1 cos g of y 1 plus x minus y whole square whole root over dy minus sin e to the power x. So at this point one can ask how to think this operator, because I am saying that I will apply the Banach fixed point theorem. So I will convert this equation into the fixed point setting. Okay, fixed point setting means in the left hand side I will keep f of x. Okay, so I will take the other terms on the right hand side. Okay, so it gives what? Half times this expression, and this expression is nothing but my operator, this one in the right hand side, but in place of f I am writing it g, in general g. Okay, and if this operator g, suppose this operator t has a fixed point f. Fixed point means what? If f is a fixed point of the operator t, so t of f is equal to f. So in the left hand side I will get f. In place of g I am writing f, because for the particular case I am taking g is equal to f, and f is a fixed point, so t of g is equal to f of x in the left hand side, and in the right hand side in place of g all these will be f, so it will be f. So if you will simplify this thing, then you will reach to this equation. So there is one-to-one correspondence between the fixed point of g, the fixed point of the operator t, and this equation. Are you getting my point? I am saying that there is one-to-one correspondence between the solution of this equation and the number and the fixed point of this operator t. Means if f is a solution of this equation, then f is a fixed point of this operator t, and on the other way, if f is a fixed point of this operator t, then f is also a solution of this equation. I hope at this point everything is clear. Okay, so we converted this equation into an operator form. Now our next task is, and we also established that number of fixed point of this operator is nothing but the number of solution of this equation. So instead of calculating the number of solution of this equation, we will calculate the number of fixed point of this operator t. So I hope everything is clear up to this point. And this operator okay, and this operator t is mapping from the x to x is a well-defined operator. One can ask how this operator is well defined, means how this image set is also in lie in the continuous function space. First of all, we have to ensure this thing. Clearly this sin e to the power x is a continuous function, we know, it is clear. And we are taking that g is from x, means g is continuous, so cos of g is also continuous, because cos is a continuous function, composition of two continuous function is continuous, and we know that this term is also continuous, so their product is continuous, and we are integrating. So therefore we know that if we integrate a continuous function, it gives a differentiable function, so this expression is differentiable, so it is also continuous. So we get this term is continuous and this one is continuous, so this expression is a continuous. So therefore the operator t is well defined, means it is mapping the x space to x space. But to apply Banach fixed point theorem, Banach fixed point theorem says that if t is an operator from the x to x and both are the and x is a complete space, normal space. In addition this, if we can show that t is also a contraction means this relation should true for some alpha where alpha belongs to 0 1 open interval, means alpha is strictly less than 1. If I can establish this contraction relation, then I can ensure that this operator t has a unique fixed point. Okay, so our next task is to establish that the operator t is a contraction. Then by using the Banach contraction principle required that t is well defined, means t mapping from x to x is well defined function, and if it is a contraction then it has a unique fixed point theorem, and this comes from the Banach contraction principle, okay, or Banach fixed point theorem. If you do not know, then search in the Google, you can find it, okay. Banach contraction principle, Banach contraction principle, okay. So our next target is to show this one, means it t is a contraction. So we will start from this difference, okay, because this supremum norm is nothing but the supremum of this difference quantity. So we will start from this difference. By then we will apply the definition of t of g1 and t of g2, and here g1 and g2 are the continuous function. These belongs to the space x, continuous function space associated with supremum norm, okay. So there then here half comes out because it is the definition of tg, so here half comes out. Then this expression will come. After that we will take the modulus inside, so there is less than equal to is coming, okay, and we will get this expression. Taking the common, we will get this expression. But and this cos function is a what function? Lipschitz continuous function with the Lipschitz constant 1, so it satisfies this relation. It is the definition of the Lipschitz continuity, okay. Here L is coming, but L is equal to 1, so it gives this one. So applying this inequality in this expression, we get this inequality, okay. Then we will take the supremum of this quantity where y belongs to 0 1 close interval. So this supremum value is nothing but g1 minus g2 supremum norm, so we can take out because it is a constant quantity, supremum value, okay. So we will reach to this integration. Then observe that here x and y, because initially x belongs to 0 1 close interval, I forgot to mention that here x we are taking in the domain 0 1 close interval, okay. Our x is lie between 0 1 close interval, and y is also varying from the 0 1 close interval, so their difference will gives highest value gives what? 1, where x and y both are non-negative and lying 0 1, so their difference gives highest to 1, so it can be dominated by this term. And after solving it, we will get this value is root 2, and here in the denominator there is 2, root 2 cancel, so it gives 1 by root 2, okay. Therefore this term is dominated by this for every x belongs to 0 1 close interval. Then we will take the supremum on the both sides, but this is a constant quantity, so there is no effect on the supremum. And this supremum value is nothing but the norm of this one, t of g1 minus t of g2, the supremum norm, and this quantity is bounded by this thing. Okay, this implies that t is a contraction for alpha is equal to 1 by root 2 and 1 by root 2 is lie between the 0 1 upper interval. So we establish that t is a contraction because it is this relation is true for all the g1 and g2 in the space x. Okay, so by the Banach contraction principle, t has a unique fixed point. Okay, but we know that number of fixed point of this operator t is equal to the number of solution. Since this operator t has only one fixed point, so this equation should have only one solution, and existence is established, and this operator has a fixed point, so this equation has also a solution, and that solution is unique. These two things are coming from the Banach contraction principle, because in Banach contraction principle is saying that this operator t has a fixed point, so this equation has a solution. Okay, so there is no solution is false, there exists unique solution, it is true, and there exists two, no, it is also false, and it has infinitely many solutions, it is also false. Okay, I hope that you all understood it very well. Thank you, bye bye.